Welcome to lesson number 6, using the constant of proportionality in an equation. And our goal is I can write an equation given a proportional table, and I can use the equation to find an unknown quantity, which means a number. So first, we want to write these are parts of our new equation, y equals kx, and we want to remind ourselves what these parts mean. So y is for the y values in a table or a graph. K is the constant of proportionality. It's also known as the K value, or unit rate. And then X represents our X values in a graph or table. So our next task, it says apply your understanding of the constant of proportionality to the questions below. So let's investigate the table. While training for a marathon, Keith's watch reported how many calories he burned at each mile marker. The data is shown below. So I see miles, so we're going to say that everything in this row are our X values. And everything in this row, we're going to consider our Y values. And we can see the numbers. This would represent 1 mile, 2 miles, 3 miles, etc. Calories burned would be 117, 234, 351, etc. So our first question says, is the number of calories proportional to the number of miles? And it says, explain your thinking. Well, first of all, we want to see if this is actually a proportional table. And in order for a table to be proportional, all of the y-x ratios must reduce to the same thing. So we're going to start, and we don't have to do this all the time if they tell us that we're working with proportional table, but since they're asking us directly, are the number of calories proportional to miles, we need to answer this question. So we're going to start with 117, which is the y, the calories burned, and its corresponding x value is 1. Then we see 234 over 2, 351 over 3, 468 over 4, and 585 over 5. The trickiest part, I think, sometimes is seeing these numbers given in the table as 1 over 117, but having to write them with the y over the x. That took some getting used to. So any number that is divided by 1 is the number that we started with. And so I want you to take a moment to see what all of these ratios are, what the unit rate becomes, if there is indeed a unit rate after you divide. Start the video up when you're done. So now that we see that all of these are the same, are constant, we can answer this question. And is the number of calories proportional to the number of miles? Yes. So we're going to write yes. And it says explain your thinking. Yes, because all of the x to y ratios are the same. Therefore, constant. And that's where that word constant of proportionality comes from. So B says, what is a constant proportionality? Well, it is 117. And before we go any further, there's a very special, if we have a proportional table, a very special ordered pair. When I have a y value with 1, if my table is indeed proportional, then my y value itself, since it's going to be divided by 1 here, is the constant of proportionality. So if we knew going into this that this table was proportional, we could immediately say the constant of proportionality is 117. In fact, this means 117 for 1, and that's what a unit rate is. So our third question says, using the constant of proportionality, the k value, write an equation. So they want us to write an equation to explain the relationship between the number of miles, x, and the calories burned, y. Then use the equation to see if it works for all x and y values above. So the equation that they want us to write is in this form. Y equals kx. And we know already that the k, which is a constant of proportionality, is 117x. So this is the equation for this table. And now what we're going to do is we're going to show that if we substitute each one of the x values, we do indeed get the matching y value that we're expecting. So repeatedly in our equation, we're going to substitute each y value and substitute each x value, the pair that goes together, and see if this equation is true. So I'm going to start with our first ordered pair. The y value is 117, and then I need to use my constant of proportionality, which is 117, and the matching x value is 1. So this would be 117 equals 117. So yes, this equation works for that first ordered pair. Now we're going to go to our second ordered pair, and I'm going to substitute 234. I'm getting that from the second y value. Then our constant of proportionality says that it's 117. I'm going to see that 117 every time I write this equation. Just the x and y values will change. Well, the matching x value with 234 is 2. So I'm going to take 117 times 2. These two, the y and the x, go together. Well, on your calculator, take 117 times 2. And we should get 234 equals 234. So that's true. So our second ordered pair was true. Now we're going to go to the third ordered pair. And I see that the y value is 351. So I'm going to write down 351. And then I need my constant of proportionality. It's always going to be 117, at least for this table. And now I'm going to substitute my matching x value, which is 3. So we're going to, on our calculator, take 117 times 3. And when we do, we get 351 equals 351. So yes, those first three ordered pairs absolutely worked with this equation, meaning that this is an equation that generated this. Would you please try the next two on your own and then start the video back to check and see if you have the same work. And hopefully you have y equals 877 and 5/10 or 0.5. And what are we talking about? Calories burned in 7.5 miles. Burned in 7 5/10 or 7.5 or 7.5 miles. So we just were able to answer the question with that equation. So now I'm going to ask you to try this on your own. We found the constant of proportionality, the k values, for these tables in lesson 5. So if you completed lesson 5, you already have the k values. Use that k value for each table to write a general equation. And you're going to notice that it's written kx equals y, which is actually much easier to use it in that form because that's how the tables are usually written. However, officially, you're going to see it written as y equals kx. So we start with the answer y based on what the constant of proportionality times the x value is. So let's recall what we did yesterday. You already did the work on this to find out that every time you put y value over x, you had 4. And then you said the k value was 4. And in some classes, I ask you to write the equation. So some of you may already have this equation. If you don't, you're going to take this and put it where the k is. So y equals 4x. So now please use this equation like we used the equation from the first table on the front to answer this question. How many cups of water would be needed for 10 cups of oil? So look at what they have. Is this an x value? Is oil x value or y value? And are we being asked about the x value or the y value? Which one are we trying to find? Well, if you notice here that the x values are talking about cups of oil and the y values are talking about cups of water, that's going to help. So see what you can do based on what we have already done. And please try that for table 1, 2, and 3. Thank you.